So the problem here is it asks a farmer has an equal number of cows in 3 different fields on his farm. Which choice could be the total number of cows? So this question is asking them 2 things. It's asking them what they know about numbers and what they know about odd numbers, and also what they know about divisibility rules. So the answer here is 207, and it's also checking to see their division facts and how they divide and the strategies that they can use to divide. So students, when they are conducting this answer, they're going to need to go through each choice and decide which answer gives them an even number with no leftovers, no remainders. The problem that's going to occur with this, and some misconceptions that kids are going to have, is when they're attacking this problem, they are more than likely they're either going to remember the odd number rule and the divisibility rules, or they are going to not remember that rule and have to use their division to check their understanding. Most likely they will also attack the problem and just look at numbers that 3 will go into evenly. And so they may end up looking at 112, they may end up looking at 266 and say that 3 will go into those numbers evenly because 3 will go into 12 4 times, or 3 will go into 66 22 times. So this could be an issue that students will encounter as well when choosing their answer. They most likely will choose, if they choose the wrong answer and choose not to use division to check their work, they will choose the A, 112, when solving for this problem. The question that I posed and thought that could end up making this problem more rigorous is to include a multiplicative comparison question. I find that those are challenging to find, but yet very challenging for students to be able to solve. So my task that I felt would enhance this and make this a more rigorous question is a farmer has an equal number of cows in 3 different fields on his farm. Which choice could be the total number of cows? So they would have a 2-part question, and then the second part would be there are twice as many horses in the fields as cows. How many more horses are there than cows? So in this part of the problem, they would need to use the division to find out which answer would be the true answer, and the answer is 69 cows are in each part of the farm. And so then they are going to need to, in the second part of this question, twice as many horses. So they're going to need to multiply the 207 times 2, not 269, because it's asking all the horses in the fields as the cows. And so at that point, they would need to then multiply 207 times 2, which is 414, as they do their computation. And finally, then the third part of the question might actually ask them to subtract 414 by 200 minus 207. So at that point, you have 7 and 2. So there's 207 more cows than horses, and then they could correlate that. They could correlate that by the rest of the answer. So the rigor, I think, comes in the understanding and the flipping of having a 3-part question and having to hang on to many different parts of that problem. So that is how I would make it more rigorous. Thank you.